Welcome to Pomodoro Joe for Sunday, July 30th, 2023. Today we're looking at LeetCode problem 664, strange printer. This is a hard problem. There is a strange printer with the following two special properties. The printer can only print a sequence of the same character each time. At each turn, the printer can print new characters starting from and ending at any place and will cover the original existing characters. Given a string S, return the minimum number of turns the printer needs to print it. All right, and then we have an example. A, B, B, B. So it's going to need 2 turns because it has to print A's first and then it prints B's. All right. Let's see, A, B, A. Well, we can print all A's first and then print 1 B in the center. So we get 2. All right. And we have some constraints. Looks like fairly small strings. Okay, so we'll put 25 minutes on the Pomodoro timer and we will get started. Now, before I get started on this, I will say I had a solution. It was difficult to explain. It worked, but it wasn't easy to explain. I found a better solution, and I want to give credit where credit's due. So this goes out to NIITS, NEETS. Anyway, you can check out their solution in the Solutions tab. And here we go. So we will make a recursive function for this one. So def strange printer recurse. So as with any recursive function, we want to break our problem down into smaller and smaller problems each time. So we'll take in a left and a right index for our string, and then we can work on converging the left and right indices. So we have a left index, that's our start index, and our right index, that's our end index. All right, now if the left index is greater than the right index, we're done. So let's just do that first. This is our base case. All right, and we can return, let's see, what do we return? Well, we can return 0. There's no printing left to be done. All right, so now we need our base result. So for this, let's just take one character off our string. So we'll print one character and then recurse on the remainder of the string. So we have some result, and we'll just do strange printer recurse. So it doesn't matter which index you choose, but we'll keep the one on the left, and then we'll just print the character at the right index, and we can reduce our right index by 1. So we'll keep the left index. And then right index minus 1. All right, so we will print the character at the rightmost index, so we can reduce our string by that character. All right, but we do need to add 1 because we just did one print pass to get this one character printed. So this is kind of the minimum amount of work we can do to reduce our problem. So we just take one character and print it and recurse. What are the other things we can do? Well, one thing we can do, we can go through our remaining string and we can check, do we have any matching characters? Can we find another character that matches this rightmost character? If we find a character that matches, so for example, we had something like, what's a good example? A, B, A. Maybe I'll do different letters. We'll do like A, B, C, B. Okay, so if we just removed our B, then we can recurse, and we'll have A, B's, and C's. But what if we actually went through and found a matching B? If we found a matching B, then we kind of can sandwich, we can split this, I guess, and sandwich our C's between these B's. Then we can print our B just one time and just print our C's over the top of those B's. So if we break this down, we can actually save one print by actually finding all these places where we can sandwich other strings within 2 of the same character. So let's try to find all the places where we can sort of sandwich these characters between similar characters. So for every, I'll call it a split index, for every split index in our range, from our left index to our right index, so now we're looking for where do we have the same character, and I'm just going to be looking at this right index character again. So if the string at this split index is equal to the string at the right index, all right, so now we have a place where we've sandwiched some string between 2 of the same character, between the split character and the right index character. These are the same character. So at this point, we have a new option. So for this option, we're going to be splitting our string into two halves. Well, not necessarily halves, two pieces. We'll have the left side and the right side. Now the left side will be everything up to this split point, up to and including this split point. And then on the right side, since we know that this split character and the right index character are the same, we can actually eliminate those characters. We're going to print those, so those are going to drop out. So both the left and the right side drop out. So let's see. Our option will be the combination of how many prints it takes, so that's going to be a recursive call here, how many prints it takes to go from the left index up to our split index, plus, so then I'm just going to do option plus equals. Now we'll recurse on the string that's sandwiched between our split and our right index. So we can drop out those two characters. So we'll actually have split index plus 1. And we'll have right index minus 1. All right. So now we have this option. We either have our current result, which is this one, or we have this new option where we split this into two pieces. We have the left side and the right side. The left side will just be everything from the left index up to this split point, up to and including this split point. On the right side, we can actually eliminate the split point and the rightmost character because they're the same. So we can drop those out and just find how many prints it's going to take to print the string that's in between those two. Now our result at this point is just going to be the minimum of our current result or this new option. Now at the end, so we'll go through all these potential split points, minimize our result. At the very end, we just return our result. Now finally out here, we have to make our first recursive call. So we'll just return. And let's see, our leftmost index will be 0, and our rightmost index will be the length of s minus 1. All right. Now this, I think, should do it. Let's run that and see how it goes. All right, so this works. Now, I can submit this, probably won't pass because we're not doing any type of caching here. But the nice thing is these are very simple. These are just indices. So we could use caching or dynamic programming, memoization, whatever you want to call it. So we could do that here. Let's submit this first just to see if we pass. Then we'll try using cache. All right, time limit exceeded. So this is too slow. So let's use this one. Then we'll jump up here. I don't think I'm just going to do this simply. We're just going to use the cache decorator. All right, let's see if this fixes it. Awesome, now we're passing. Let's submit that and see if we can pass all the tests. And we pass. All right, and we do really well actually. We beat 85% for runtime and 40-something% for memory. I honestly can't read this red on black, but anyway, we beat 85% for runtime, 46% for memory. Yeah, that's pretty awesome. Now we could jump back really quick and do my little trick where instead of using this min, we do our own min. So we'll do result. If result is less than option, otherwise option. So this might save us a little bit. Let's see. Not really, it's about the same. 85%. Yep, it's exactly the same. All right, it was worth a shot. Okay, again, I do want to say special thanks to NIITS for their solution because it's way better than the solution that I had. So, all right, so this is it for me. Hope you enjoyed this. Hope you had fun. Hope you can go out and write better code.